We'll take a really deep look into the activities in Kotlin once we get into our demo. For now, let's talk about Android views. Let's look at the smallest component that makes up the interface of our app, including controls from the most basic of buttons to the most complex of adapter-driven recycler views. UI components are broken into two main categories, the first of which are views, the things that we've been talking about this whole time. The basic definition of a view is a simple UI component with a collection of properties and functions. These views can live next to any other view, but cannot have child views. Then we have view groups. These inherit from views in that they also are UI components with properties and functions, but they also contain child views from one to any number of them. They can be used for layouts or for creating more complex functional controls from a collection of simpler views. We can logically break views into three categories, the first of which are layouts. They allow for structuring collections of views in different ways, whether they're stacked, grid, relative, or changed depending on the orientation of the device. The second are basic components. These are used for displaying content and receiving user input. You can think of basic components as elements in a form or in a detail view. The third are structural and advanced components. These help provide advanced and interesting user experiences, help structure the flow of the application, and enable complex features by combining other simpler views and layouts into one comprehensive control. Android ships with a number of layouts we can use, and there are more that are provided by the Android support libraries and from the community. From Android we get a linear layout that stacks child views either vertically or horizontally, a relative layout that allows for child views to be positioned relative to other child views, or the parent layout, a frame layout that positions children absolutely based on their width, height, margin, etc., and a grid layout that puts views in rows and columns. We also get some unique layouts from Android support, such as the coordinator layout that is similar to the frame layout but allows for child views to attach behaviors based on events within the layout, or the constraint layout that is similar to the relative layout but makes it easier to position elements in the designer view. We also have access to a large number of basic components. To name a few commonly used control types, we have edit text for user inputs, text views for rendering text and styling it, buttons, switches for handling bool values, pickers for different selectable options, dates, and times, and image views for rendering images within them. Structural components that are built on other simpler views or layouts are pretty cool. They have some unique features and make it easy for developers to unlock complicated functionality more easily. Some examples include toolbars and action bars, along with all the different controls within them. Tab layouts and tab bars for organizing changes in content from tabs. The new bottom navigation view, which is similar to tabs. A navigation drawer, aka the flyout menu. And a scroll view for allowing our content to scroll in any direction. Lastly, we have the advanced and unique controls. These also have some interesting functionality, but aren't necessarily used for structuring the app as the previous controls are used for. Most of these views come from Material Design and the new set of controls Google created to fulfill the need to meet design standards. These include things like Toast in the new Material Design snack bar, the floating action button, bottom sheets, expansion panels outside of the toolbar overflow menus, custom dialogues, and finally lists, grids, and recycler views. List grids and recyclers are also considered layouts due to the fact that they control the layout of other child views. However, they use adapters and view holding with recycling to render large amounts of content in an efficient manner. Android handles views in two primary ways. First is with Android project resources. Resources include a slew of different types of files that we'll talk about shortly. These include the XML files that represent the markup of our views. We will also use our code to interact with the views. This allows us to reference the XML layout resources as well as create new views in source code to manipulate within an activity or a fragment. We'll be doing plenty of this in our app using Kotlin. Here's an example of an extremely simple Android XML layout resource. It represents a single coordinator layout mentioned earlier with a text view and a bottom navigation view. Each of these views contain a number of properties in order to position them properly in our UI. The only two required properties in a view are layout width and layout height. The rest of these represent extra information to help with positioning, styling, and more. This may seem like a lot of text to create such an incredibly simple view, and you're right. Luckily, we have some awesome tooling within Android Studio to make our lives easier. We can use the designer view of our layout file to see a number of different windows that help us better create our interface. We have a toolbox on the top left to allow us to drag new controls into the view, a hierarchy of views just below that to allow us to select a certain view more easily, as well as visualize the parent-child relationship of all our views together. We also have the main design view that allows us to move around selected controls and see information about them, and a window to the right which shows all the properties of the view we have selected. We can also edit these properties right here on the right. There are some other great features to this view that we'll be able to showcase during our demo, such as switching themes, rotating the phone, showing or hiding the blueprint, changing the type of phone, screen size, and more. Now that we've designed our view in either the XML editor or the designer view, we need to be able to use our views to update and manipulate them. This is where we write our Kotlin code within our activities, fragments, or other areas that reference our views. In this example, we're in an activity and we want to set the text of our text view to Hello World. In Kotlin, we override the onCreate, call setContentView to reference the XML layout resource we created, then get the auto-mapped message text view and set the text property. This seems intuitive, but there is a lot going on under the hood of Kotlin that is secretly making our lives so much easier. For example, auto-mapping the text view by its ID in the XML to a property on our activity, as well as mapping the Java setText function to a property that is settable in the TextView class. Let's take a look at the exact same thing, but in regular old Java. We have to manually get a reference to the text view and set it to a local variable by using the findViewById function with an explicit cast. We then have to call the setText function and pass in the Hello World string.